smart house and IoT systems section of the first international workshop on intelligent and cyber-physical systems, ICyberPhyS-2024. My name is Olga Pavlova. I will be leading this section, and let me introduce you with the presentation timing. We have 10 minutes for the presentation, for session presentation, and 5 minutes for questions and answers section. It means 15 minutes for each presenter. And our first presentation is by Орест Хамула, Олександр Тимченко, Світлана Васюта, Ольга Сосновська, and Solomia Dorosh, development of font selection method for text content in immersive technologies. Are the presenters here?
Yes. Good afternoon. Today I will present
Dear Olga, we cannot hear you. Once more again, please.
Do you hear me now?
Everything's all right.
Okay, great. Good afternoon. Let me share my screen again. Do you see my screen?
Yes, we do.
Okay, great. So let me introduce our research development of font selection method for text content in immersive technologies. The authors are, as you already mentioned, Олександр Тимченко, Ольга Сосновська, Орест Хамула, Світлана Васюта, and Solomia Dorosh. The content are as follows. Information has always been a powerful tool for attracting people's attention. Facts, figures, and experts' analysis are very persuasive when presenting certain information. For high-quality publication, content including text should be presented as intuitively and clearly as possible. The main rule when selecting a font is to ensure the readability of the text. It is also important to study the factors that influence the font design of a particular publication. The use and combination of font in traditional print publication are well studied due to their millennial of use. In contrast, electronic publishing is relatively young, and the processes involved are not yet sufficiently explored. The application of font in electronic publication remains largely uncharted and requires additional research. Also, there are numerous publications offering studies and recommendations on font usage and parallelinks in electronic formats. The purpose of this study is to determine the important font characteristics prioritized by experts in the creation of products using immersive technology. The stages of development of the method of the font design selection for text content include 4 steps. First is abstraction and generalization. Second, comparison, questionnaire, and generalization. Third, pairwise comparison, expert analysis, cluster analysis. And the last but not least, pairwise comparison, system analysis, matrix analysis. In order to highlight the font selection criteria, the method of abstraction and generalization is applied. In order to determine the superiority of criterion one over another, an expert survey of 15 third-year students of publishing and printing specialty is conducted. The first stage of development, the method of font selection for text content includes determining the parameters that affect the text design and style. They will provide the opportunity for a designer to choose a design and accordingly decide on the font type of the design. To assess fonts, a study is conducted and 9 parameters are proposed, which determine the most common characteristic of font selection for various projects. All features can be combined into groups, including first, its font contrast, second, font dynamics, font cost, font openness, font weight, language, weight, emotionality, and size. This characteristic will be used as font assessment factors for the design in infographics. As for fonts in general, their characteristic and division can be presented in the following diagram that you can see on the figure 2. Using the method of pairwise comparison, a pairwise comparison of factors is performed. This method helps to rank or select options based on their relative importance. First, let one create a list of all alternatives that should be compared or ranked. For each pair of alternatives, pairwise comparisons are conducted in terms of characteristics that are important to decision-making. Next, the importance of weight of each characteristic or criterion relative to the other is determined. For each alternative, total score are calculated on a result of pairwise comparison and factor weights. Experts use a 9-point scale, in which first is the lowest score and 9 is the highest score, respectively. The concordance coefficient is used to determine the degree of agreement or consensus between experts. The concordance coefficient is calculated accordingly to Formula 1-2. To obtain value of concordance coefficient indicated the proper consistency of expert assessment. The obtained value of the concordance coefficient indicate the proper consistency of expert assessment. The obtained ranks show the result of an expert assessment for font characteristics, which act as criteria for selecting the font design of the text. Rank 1 is emotionality, rank 2 weight, rank 3 font context, rank 4 rank 3 font contrast, rank 4 font cost, rank 5 font dynamics, rank 6 font openness, rank 7 size, rank 8 language, and rank 9 font weight. On the basis of a calculation points, one can rank or select the alternative according to their importance. The method of pairwise comparison helps to structure the decision-making process and make it more objective, since it depends on the subject assessments and weights given by each factors. If the ranking method is used correctly, it can help avoid subjective biases and facilitate objective decision-making. On this slide, you can see visualization of font assessment result according to font characteristics factors. The result of assessment show that the greatest inaccuracy is in determining the emotional component of fonts. After all, the emotional component of font perception reflects what emotion, association, and moods the use of certain font in the design of text or graphics evokes in people. This component determines how readers react to the font on a psychological level. The obtained assessment is presented in the form of diagrams that you can see on the figure 4. The font is considered one of the most important, interesting, and complex tools in the arsenal of designers for various types of the text content, including for immersive technologies. At first glance, it seems that the font should only capture the specified text content and cover its meaning. Of course, the main purpose of any inscription is to convey a certain message, but the shape and color of inscription will also affect us. Since the reader's emotional state is the result of the user experience, the font perception also depends on the cognitive level. Fonts directly affect the appearance on the screen. Depending on the amount of text that it is provided to the reader, it is necessary to select a font that will improve the positive atmosphere and perception of the content being read. The designer's selection of inappropriate font can cause negative emotion and, as a result, a critical assessment of the interface of any resources. This research represents an initial attempt to recommend font usage for publication created with immersive technologies and will require further validation and additional studies. From the above, it can be concluded that the developed method of font selection for designing the text content of publication in immersive technologies make it possible to single out the font parameters that affect the legibility, design, and style of text information. Fonts are studied according to the criterion of the emotional component on perception, which reflects what emotion, association, and moods the use of certain font in design evokes in people. This component determines how readers react to the font on an emotional level. Recommendations are provided for the selection of font design of text content in publication created with the help of immersive technologies. Thank you for attention. Maybe you have any questions?
Thank you for the presentation. Dear colleagues, any questions, please? Dear colleagues, maybe somebody has a question to our presenter. Okay, then I have a question. Could you please tell us the further steps, the further maybe perspectives of this work, and how would you like to implement it?
Yes, thank you for your question. Of course, we will I suppose we will provide new surveys and include more people to the surveys to understand the emotional side of the fonts, yes. And after that, also we will include publishers which has worked with immersive technologies. And on this research, we'll make some conclusion, and I hope we'll make some new paper and we'll come to you as well.
Thank you so much for the great answer. Dear colleagues, more questions, please? If there are no more questions, then we thank to our presenter and we go to the next speech that is by Nikita Tarasov and Oras Hamula, Factors Influencing the Creation of Trial 3D Models in Additive Manufacturing.
Hello, dear colleagues. Hello, everyone. So I will present research paper. Just a moment. I will share the screen. Do you see my screen?
Yes, we do.
So, factors influencing the creation of Braille 3D models in additive manufacturing. So, contact. First will be introduction, and after this we will discuss about problem of statement and research and main results. So, first, additive manufacturing. Additive manufacturing, known as 3D printing, is a method of building objects models, prototypes according to a digital 3D model. This process is called layering or growing because models are created layer by layer. In additive manufacturing, various 3D printing technologies are used. The main 7 categories, but we will highlight only those technologies that were used to create Braille 3D models. First, material extrusion, fusion filament fabrication, fusion deposition modeling. So the next category is binder genetic, material genetic, powder bed fusion, and wet photopolymerization. So for powder bed fusion, we have selective laser sintering and selective laser melting. So the next, inclusion. Additive manufacturing technology allow creating high-quality tactile Braille models, thereby developing inclusion and accessibility to various spheres of life for people with visual impairments. Using 3D printing, tactile models can be created quite quickly and even at home or in educational institutions, compared to other traditional production methods that require a specific production environment. Today, inclusions need more active development so that people with visual impairments can easily receive services, read information from external sources, and receive a high-quality education. So, cycle of additive production process. First step, it's the choice of software for creating a digital 3D models, and at the same time the type of 3D printing technology, 3D printer, slicer, materials, complexity of bright text. First process it create a digital 3D model or scan an existing model. Second step, formatting a file from a digital model to a format for 3D printing, STA, EMF, and etc. It's need for reading the instruction AG code by 3D printer. Setting parameters for 3D printing. It's setting support structures, displacement, material selection, layer thickness, filling, trajectory, speed. So, printing the model on 3D printer, and after this last step, it's post-printing processing, cleaning from auxiliary resistance, smoothing, etc. So, main problem of statement and research. In this study, the main attention will be paid to the study factors that affect the reproduction quality of Braille 3D models used by people with visual impairments. This line of research was chosen because there is need for the development of inclusion, and this case for people for visual impairments. Therefore, it's necessary to improve the quality of inclusion, thereby applying additive manufacturing technologies to create tactile models. So, and also we need to determine how each process affects the creation of 3D model. As a result, it will allow to improve production process. Determining the importance of factors that influence. So, as the direction of our research in additive manufacturing process is focused on the factors and process that affects the quality of creating 3D models and the formation Braille on them. In this research, a number of key factors and processes are identified that can affect the quality of creating 3D models with Braille. Another area of research studies is the role of additive manufacturing. The study of process and influencing factor refers to complex process in additive manufacturing that cannot be characterized by certain values that could be used in calculation. But such calculation can be performed by a number of methods, including the analytic hierarchy process method and the ranking method, which have proven themselves well in practice. This study will use the analytical process hierarchy method because it uses dimensionless factors, values, thereby neglecting to reduce the study values to the same dimensions. This method was proposed by the American mathematician Satie, which is based on pairwise compression of factors that are selected with the help of respondents and are recognized as important when considering this process. So, determining the priority of factors influencing the quality of creating 3D Braille models. Main method is determining the priority of factors influencing the process Braille formation in additive manufacturing involves a multifaceted approach. So, as you see, we have FAB equal 0 if factors, some factors does not depend on factors AB, 1 if factors depends on factors AB. So, first factors is we decided material properties. So, the type of material used in additive manufacturing can significantly affect the quality of Braille dots. Properties such as hardness, elasticity, and melting temperatures need to be considered. So, we have calculated material suitability indexes, could be calculated as MSE. So, we choose only main materials. It's ABC plastic, PLA, patch, and nylon. So, we calculated hardness, elasticity, temperatures, and we got MSE. So, the next, also we have calculated printing resolution. You can see we have RP nozzle diameter and on layer height. Also, dot height and spacing. The height and spacing of bright dots are crucial for tactile readability. So, dot height, dot spacing, and dot diameter. Environmental factors and user sensory testing. Based on this mathematical calculation, an experiment study was carried out. The material was chosen, the printing ability of the 3D printer, the quality of the bright model's points. So, based on these factors, the priority of parameters and factors that affect the quality of reproduction of bright 3D models was revealed. So, 5. Selection of factors influencing the quality of creating bright models. Level 0 is software for creating bright 3D models. Level 1, difficult of creating a model and text. Level 2, software slicer. It's pre-press preparation. Level 3, it's type of 3D printing. Fourth, it's a 3D printer, type of 3D printer. 5, it's selection of materials printing. And level 6, manufacturing environment. And last level, post-press processing. So you can see this table, software slicer, so software creation text braille, slicer, and etc. We have this initial graph of the relationships among the factors. So as you see, we have this relation between this. So we have described level 1, influencing this factor effects to the complexity of creating braille models. So on software and functionality, and also on 3D models influence. So level 1 also influencing on the factor 5. Level 2 influence for factors 3, 4, and 5. So, and I will not to focus on this because we don't have a lot of time. So, but you see how it influences. So, final results construction of a multi-level structured model of priority factors. So you see, level 5 is the selection of materials. It's a high priority. The next level is level 3, type 3D printing. So the next also level 7 is post-processing. Level 2 and level 4, the choice of 3D printer and slicer. So, but the least important factors were the complexity of the 3D model, the selection of software and environment. Also, this factor should also be considered when creating 3D models. So you see hierarchy model. Discussion. Creating of model in additive manufacturing is a rather complex technology with many different processes and with many different factors that affect the quality of creating models, including the Brown formation. Consider these influencing factors at each stage of the manufacturing process. This will prevent defects and improve the final result, while ensuring high quality and reliability of 3D models, including. So, this manufacturing process or factors are interrelated one by one. Select this or that technology model, a brand of 3D printer materials are dependent on each other. So, conclusion. As a result of conducted research, we will receive the following perspective and novelty. For the first time, the factors that influence the quality of the creation of brilliant 3D models at each stage of the additive manufacturing process have been identified, on the basis of which a semantic model and hierarchy model with influence factors from the highest to the lowest factors have been built. This makes it possible, first, improve the quality of additive manufacturing process from the creation of a digital prototype. Second, improve the quality and expand accessibility to various spheres of life for people with visual impairments. And number 3, speed up the reproduction process of Braille models. So But the other side of the study has certain limitation, since this work investigated general factors that affect the processes of reproduction of broadly 3D models. But in the future research, we'll focus on the identified factors, such as temperature for applying layers to the model, the working mechanism of 3D printers, etc., as well as the creation of new information system and the use of artificial intelligence, such as computer vision, neural networks, which will be integrated to each stage of additive manufacturing and learn from all processes, from the creation of a digital prototype to the elimination of defects after printing. So that's all. Thank you.
Thank you so much for the presentation. Dear colleagues, do you have any questions to the presenter? You're welcome to ask the questions. Okay, then I will ask the question. Really impressive and interesting and relevant at the same time work. Could you please tell us what inspired you to conduct such a research and complete such an interesting and relevant work?
Yeah, so we have a lot of experimental in the laboratory. So, and also we tested 3D Braille models, but we need to make a lot of experiments because it's not enough for us, and we will research this. So, but it was hard to find some people who will be ready to test 3D Braille models. But we tested only no visual impairments, but but tested this who know Braille text. So.
Thank you so much for the answer. Dear colleagues, more questions, please. Then we would like to thank for the presenter, and we go to the next presentation that is by Світлана Хованко, Марта Лобацька, Микола Гаванко, Валерій Житайський, and Volodymyr Litvinenko. Diagnostics and assessment of imprint quality using pattern recognition methods and digital photography for image processing. Are the presenters here?
Yes, please. Could you please turn on the record?
Yeah, we will do it. One moment.
Now.
Dear colleagues,
Do you hear?
let me present to you
Yes, we hear and see.
Okay. The results of research on the topic, diagnostics and assessment of imprint quality using pattern recognition methods and digital photography for image processing. The structure of the presentation of the results of the research involves the following content: introduction, objects, and methods of research, analysis of methods for diagnosing the quality of printed images and results of the research. The modern printing industry uses various technologies for printing and finishing products using a wide range of image carriers: paper, cardboard, microcorrugated cardboard, synthetic films, fabrics, etc. Printing enterprises that operate effectively on world markets rely on fast and reliable technological equipment that is the production of high-quality products. Therefore, an urgent task is to improve the existing and create new diagnostic methods for assessing the quality of printing and packaging products. The object of the study was imprints of offset, flexographic, thermal transfer, and digital printing. The methodology for assessing the quality of printed images on various surfaces provided for the use of a diagnostic device model, the principle of which is based on modern laser technology of digital photography and pattern recognition and optical methods of data selection, the scheme of which is shown in Figure 1. In imprint diagnostics, when turning on the PS power supply unit, laser 1 and light source 3 are turned on. The beam of the laser ILB with the help of System 2 is directed to the area of the image VS of the imprint, which is placed on the table. At the same time, optical illumination IOR is directed to the same area by the optical System 4. After hitting the surface area VS, the reflected optical rays RR are registered by digital camera 5 and the reflected laser beam RLB by camera 6. The registered images are submitted for analysis to a PC, where spectrodensitometric indicators of the image are calculated according to a mathematical model, taking into account the texture of the printed substrate. High and reliable quality of imprints in all printing methods is provided by properly prepared original, high-quality printing plates, materials, and planned and organized production process in the presence of control and measurement systems that effectively control the printing process in dynamic mode and in real time. To detect the heterogeneity of the structure of the printed material, the following can be applied: the theory of raster structures, stochastic spatial geometry, the theory of pattern recognition, and digital photography for image processing. The use of these methods, which have proven themselves well in providing constructive diagnostics and are known in theoretical and practical mathematics, as well as the use of computer programs for processing digital images, makes it possible to control and identify defective signs that caused a lack of products on various image carriers. To assess the structural and dynamic distortions of imprints, an urgent task is to adapt the methods of digital registration and image processing to identify the characteristic features that provoke the lack of products on film, fabric, and paper materials. Accordingly, the following tools can be used to detect the spatial structure of low-quality areas in the places of printed images in the diagnostic mode. Computational geometry, stochastic spatial geometry, pattern recognition theory and fuzzy classification. Methods of digital graphics and photography for processing lack areas of images. So, the methods of modern digital photography and laser technologies make it possible to build diagnostic systems for printed products made by any printing method. The use of methods of computer graphics and digital processing and recognition of electronic images provide a constructive diagnosis and are the basis for the selection and classification of factors of influence of hardware, software representation of images, and parameters of input materials on the quality of products. The process of diagnosing the quality of imprints based on image distortion during printing can reveal features that are informative for decision-making when evaluating imprint quality. On this slide, you can see the main features of distortion. For clarity, as an example, this slide shows microphotographs of the morphological structure of the surface of offset imprints on cardboard and their 3D models. The conducted studies confirm that the presence of a coating has a significant effect on the microgeometry of the surface. This layer changes the roughness parameters and the area of peaks and valleys on the cardboard. The roughness parameter for cardboard with 3-layer coating is 2.75 times smaller than for cardboard without coating. This slide shows cluster structures that appear due to temperature inhomogeneity of the matrix field and local deformation of the film. Such phenomena are related to the fact that the speed of the thermal printing element is limited by the low cooling speed of the thermal printing head, which especially often occurs during printing at high speeds with large printing volumes. Graphic defects in the form of clusters can also be considered the cause of the morphological features of the material being printed, in this case, textile polyester tape. It is known that the polyester tape, which is used for applying images by thermal transfer printing, has polyester weaves, which are characterized by the formation of the front surface due to the overlap of the weaving threads, as a result of which longitudinal and transverse scars are formed. This surface structure of the polyester tape impairs the quality and uniform application and fixing of the ink over the entire surface of the printed material. Algorithms for the diagnostics of the printing system can be represented accordingly based on the test structure in the form of a quality algorithm. Based on the adaptive classifier of imprint quality, decisions are made regarding optimizing the printing process. The algorithmic structural scheme of the adaptive classifier of the diagnostic process includes the units that you now see on the slide. The diagnostic procedure based on the selected quality criteria should include a classifier of printing distortions and combine it with a method of image perception of printing distortions by a person and a machine recognition system, which performs the functions of an intelligent classifier of the image, current and reference, of the printed element. The conceptual model of quality control includes the following approaches and methods. Laser control of the structure and properties of the material. Laser illumination for assessing distortions of microelements of printed text and graphics. Digital photography for evaluating the microstructure of fabric materials with laser illumination, fluorescent light, and white, matte, light. Microscopy of samples, fine structure. Digital image processing and scaling and defect detection technologies. Analysis of the dynamics of transitions in digital automata under conditions of disturbances, synchronization, and power failures. Analysis of the impact on the quality of information and energy sustainability of the automated technological process management system. Analysis of the influence of the vagueness of management and testing strategies of the hardware and software complex on the quality of imprints. Analysis of the nature of the printed elements by methods of stochastic geometry and methods of image recognizing of elements on imprints. The synthesis of the intelligent classifier system can be carried out for the following modes of product control. Continuous control and detection of defective prints based on the concept and methods of pattern recognition and decision-making. Selective control by the methods of digital photography and its combination with the operator's visual assessment. Complex recognition and diagnosis of defects by combined methods based on printing test images of elements. This approach provides the most effective way of diagnosing and classifying imprint defects. According to the diagnostic scheme, groups and classes of factors influencing the process and printing quality can be distinguished. Instability of the mains voltage, which affects all elements of the printing process control system. Change of printing modes, which leads to changes in printing parameters. Software failures, informational and technological defects. Failures in the control system of the synchronization process and the printed substrate supply drive, ink, varnish, etc. Defects in the structure and physical and mechanical properties of materials. Shortcomings of technology and wear and tear of the mechanisms of the printing press during operation. The problem of diagnosis is complex and systemic and requires modern research methods based on laser and digital technologies and appropriate mathematical support and software for material selection and recognition of defects in printed images on imprints for its solution. Approbation of the proposed method for evaluating the quality of images confirmed the influence of the structure of the printed substrate on the value of optical density, contrast, print stability, and color characteristics, which contributed to the reduction of the number of defects when printing products. Thank you for your attention.
Dear colleagues,
Thank you for the presentation. Dear colleagues, if you have any questions to the presenter, you're welcome to ask. Dear colleagues, questions, please. I have one question. Dear Marta, could you please tell us what are the further steps of your research and how do you plan to implement it?
Thank you for your questions. I'm sorry, I have a bad internet connection, so I will answer quickly. The implementation, our study, our researchers have very complex character. So we hope that our decision of the problem of diagnostics is, how I told before, is complex and systematic and requires modern research methods. And we hope that approbation of the proposed methods will help for the printed products manufacturers to improve the quality of imprints on different materials. It can be cardboard or paper or film. So it will be contribute to the reproduction of a number of defects when they manufacture of printed products. Thank you.
We have more questions. Natalia, please.
Good afternoon. I want to ask you, what about internships developed in this field? Maybe your research this sphere. International internship, maybe I can translate on Ukraine, про міжнародне співробітництво в цій сфері. Можливо, є якісь передові, можливо, можете відмітити якусь країну. Дякую.
Sorry. We have different internship connections between our Poland friends from Lodz Polytechnical University, and we work in these directions.
Thank you.
Thank you.
Thank you so much for the presentation. Dear colleagues, if there are no more questions, then we go to the next presentation by Sergey Lysenko, Olaf Bontaruk, Piotr Gai, and Inna Martinyuk, method of optimizing delay in IoT system using fog calculations. Is the presenter here?
Yeah, sure. Dear colleagues, do you hear me?
Yes.
Here are some results of our team, method of optimizing delay of IoT system using fog calculation. And let's talk about agenda. We have some few words about motivation, idea of the research, some aspects of methods and results. So fog computing is a system-level architecture that helps achieve optimal distribution of network computing power and information storage. Fog computing combines the advantages of cloud and edge computing to provide high quality of service, reduce latency, ensure mobility, and other functions used in modern computing system. The application of fog computing provides a higher speed of data processing since the computing power is closer to IoT devices at the geographical level. So here you can see the main characteristics that includes fog computing, such as low latency, rich and diverse support for devices, multi-user control environment, support for mobility, complexity, geographical distribution, wireless access, support for heterogeneity and device compatibility, real-time analysis, industrial use, etc. So in order to optimize the delay in the IoT system using fog computing, the task was scheduling method based on the colony optimization algorithm was improved and implemented to execute priority for different classes of tasks in the system. So here you can see the method steps. First is definition of classes of text that can be proceeded about nodes, allocation of priorities between classes of tasks within each of the fog nodes, in determining the response delay of nodes using the colony optimization algorithms, and adjusting the results of determining the efficiency of nodes using the priorities of task classes for the current load of the fog nodes. So here in the work, colony optimization algorithm was used, which showed the best result in optimizing the reduction of response time when planning tests. So to reduce the average processing time of tests, it was decided to add a priority condition for tasks on fog nodes. Thus, the fog nodes will focus computing power on certain classes of tasks and accordingly process a larger number of them per time unit. So in this case, the suitable environment required that gateways with load balances must be present in architecture. Such gateways will act as task schedulers. Since each gateway will have information about each fog node, its task classes, workload, and response time, it can effectively plan by distributing tasks. So here you can see architecture of gateway and IoT devices in the system. In this case, a network of fog nodes connected by task class. Task classes are marked with geometric figures. In this way, optimization will take place by class of task. And it follows that instead of the total number of fuzzy nodes, each search of the fastest one will take place among the set of nodes performing a specific class or classes tasks. As well, an architecture where gateways act as a task scheduler, they receive tasks from IoT devices and schedule the task depending on its class using the fog network response delay. So here you can see the network table with response latencies. It includes a fog node, a task class, and response delay of each node task for some class. It can be seen that some node performs some task, and however, some node should have a higher priority to perform some task, and some node should have a higher priority to perform another task. In this, we have some formalization. We have to minimize the node with the smallest response delay. In this case, sensors can generate a large amount of data at a higher frequency, so there may be cases where all of the fog nodes and the cloud environments are overloaded. In this case, the data received from the sensors may be lost. Often, such data loss may not be critical, but there are areas of IoT where low latency is a major system requirements. For such a case, it's proposed to introduce the priority of task classes. In order to determine the total load of the node which task, we will introduce this formalization, which will take into account both the number of completed tasks and the complexity of their processing. So includes the total load of node, the time window which with the calculation are performed, which is necessary in order to keep the memory only relieve relevant data on the processing task, and the time within task was completed. So in this case, we have abilities that the task schedule will be able to take into account the total load nodes. And all the values are calculated using previous formula, where the value of some seconds and values of the counters were generated with the time window. And here you can see the value of the total load of some node. In order to perform experimental results, the dissect CF simulation environment was used. Here it is includes some characteristics of components such as frequency, task size, instance instruction count, threshold of application strategy, IoT price, and such parameters of the microcontroller components such as CPU, memory, processing power, repository, turned on trend of processes, minimum power, and so on, which is able to make some simulation in order to obtain and to evaluate the load of the node of the network. So here you can see some parameters for fork network node settings, as well as cloud environment settings parameters. And this slide presents the parameters of the software environments. You can see the location of nodes and also the device routes. Device routes were built based on the principle that one device should be covered by several fork nodes. A route was built in which, in certain areas, the device will not be covered by any of the fork nodes. Instead, the load of the network of fork nodes, 200 end devices constantly moving along the roads and sending data from sensors were used. To compare the results, two models were used, one of which is based on the developed method of planning test in the IoT infrastructure used for computing, and the second one was hold down planning strategy. It's a built-in planning strategy in the dissect fork environment. Here you can see the result of simulations, and this is a graph of task planning comparison with developed strategy and hold down strategy. As you can see, the task scheduling graph shows the number of scheduled tasks. The result is caused by the details of the work of the developed algorithm based on task priorities. The algorithm schedules tasks in order of arrival, but when the maximum value of the count of the task class is reached, the algorithm starts to schedule tasks with higher priority. Furthermore, here we can see the energy consumption with priority on heavy task power consumption. The values of energy consumption by node processors for the developed planning strategy are greater than the hold-down strategy. The obtained indicator is the result of the fact that algorithms began to perform more tasks with high priority and low latency. And here you can see energy consumption with the figures in developed task planning strategies, so a better result of the delay in the execution of some class tasks. This is the result caused due to the fact that the planning task placed according to the planning algorithm based on the priority of the task. So here is the result. As a result, we have produced some method which enables to optimize priority of tasks, such as in the infrastructure that use the advanced IoT infrastructure optimization method using fog computing. The response time was reduced by 30% in some cases for some classes tasks with low processing time. However, the response time for tasks that required more processing time, the increase value was about 6%. So the third method might involve you approaches to decrease delay. Thank you for your attention. Maybe you have some question.
Thank you so much for your presentation, dear colleagues. Please, your questions. Yeah, we have two questions. Please, Victor was first.
Good afternoon. I have such a question. Do you use the same, or are the fog nodes you are here you are testing all equivalent, or do you use some different types of these fog nodes, different, for example, different performance of these nodes?
Yeah, sure, but here the task was to firstly to give heavy load and to find out the most appropriate values To do this, of course, we used end-kernel optimization algorithm, but your question, it's mainly will be the next research, because it's very important details, but it's a very huge experimental part. Yeah, thank you.
How do you allocate, thank you, how do you allocate how do you allocate the priority to the task? Are they all equivalent as well, or you make them depending on something?
We make different values. We try to give different priorities for different classes, and the task was to divide into several classes, and after that make some optimization.
So you divide them
processes.
depending on the class actuality or
Yes,
past
yes,
actuality in the class, like
yes.
that. Okay, thank you.
Yes, we combined into classes by the priority. Yes, and it gave us some good results. Thank you.
May I ask a question, Sergey?
Yes, please.
First of all, thank you very much for the nice presentation, right? And based on the slides, you've shown that you use about 4 GB of the memory, and voltage is about 1 to 3 watts. I mean, power consumption, right? So I assume that, okay, you work with fork end devices like Raspberry Pi 4B or ESP32, right? And my assumption that you ignore Arduino Uno, Mega, and ESP8266. Am I correct?
Actually, it was simulation, and according to these, we tried to simulate. It was devices sound like Raspberry Pi, of course, but if we use devices with lower execution potential, of course, we will obtain another results. But we didn't take it into account yet.
So you start just with Raspberry Pi 4B, right? And you
Yes.
ignore Arduino. Okay. Another question:
At the moment.
Okay, no problem. It's okay. It's your choice. And for the time being, how you plan to connect these fork end devices? I mean, for instance, MQTT protocol, I2C protocol, COAP protocol. How you plan to connect them?
Our next, I suppose that it will be good research to try all of them and compare with different issues such as defense, such as stability, such as possibility to apply our method. It's a good idea. Thank you.
You're welcome. Thank you.
We have one more question. Please, Pavlo.
Yeah, thank you very much for your talk. I wonder, and I would like you to clarify what optimization criterion did you use within your method, and what optimization algorithm was also used to reach the best solution. Thank you.
Actually, we just tried with our young team and colony optimization algorithm, and actually for this task optimization, maybe it's one of the best, but we will try another maybe optimization algorithms. And according to your another question, it was to divide payload as possible as with low latency, low delay as it possible. That was the main criteria.
Okay, great. Thank you very much.
Dear
Sergey,
colleagues,
one question if possible.
Yeah, sure.
Sorry, Olga, I don't know why, but in my Zoom, I cannot raise my hand. So one more question. Can we say that your optimization criterion is about minimization? Sergey?
Yeah, sure. Yes, it was, because it was formalization formula presents the minimization. Yes.
Okay, thank you.
Thank you so much for the presentation, dear colleagues. We have one more presentation in our agenda is by Viktor Malnik and Anatoly Malnik, Method and Framework for IoT Nodes Self-Configuring with Cloud-Based Automatic Design and Synthesis Tools. Are the presenters here?
Yes, I am.
Okay.
Can you hear me? Can you hear me?
Yeah, sure.
Yes, okay. So my name is Viktor Malnik. It's nice to see you on this event. Nice to meet you, dear colleagues. We are representing 3 different institutions. So I would like to present the mentioned topic. The agenda will be as follows. I'd like to briefly talk some things about IoT technology, cloud, edge, and fog computing features, some essential characteristics of modern IoT systems, new challenges in them. Then we will state the problem. We will see the structure of IoT node, the approaches to process data, some examples of FPGA-based IoT nodes, and challenges of this node application in the IoT systems. And afterwards, I will present you the method and framework for self-configuring FPGA-based IoT nodes in IoT systems. We will also finally discuss the benefits of them and conclusions. So I think we all know about IoT technology. So this is like Internet of Things. It's like Internet of Human, where but things are communicating with each other. And today we can observe that IoT nodes collect really huge amounts of data, and this data must be stored and processed by appropriate computing and storage resources. So today, in contrast to previous and early IoT systems, the major computing power is shifted from the cloud layer, where the computing systems were centralized, down to the fog nodes and edge nodes. Therefore, we have the requirements imposed to the latest IoT systems, which are high computing capabilities, mobility, serviceability, and some more, of course. What are the essential characteristics? Some of them, of course, not all, but essential computing, essential characteristics for the IoT systems. We see contextual locations, for example, geographical distribution, heterogeneity, interoperability, real-time interaction, what imposes additional requirements to the performance, scalability, dynamic configurations for different applications, what is very, very important. Data processing acceleration. Again, it's regarding the high performance. So there are new challenges in such IoT systems of the last generation, which require new architectural and technological solutions. Firstly, we can say that we have resource-constrained IoT devices like sensors, actuators, data collectors, and so on, which often have to perform quite intensive, computationally intensive tasks. Secondly, there must be, in many applications, there must be uninterrupted and safe operation guaranteed, which becomes a top priority task. And for example, when we need to perform some updates, some upgrades, and so on, for example, on cars, yes, or on devices in cars, we have to bring them to technical stations. And for example, we can therefore we will interrupt the operation of the system, and it could result sometimes in losses in costs. And another one, we see the number of security challenges which are related to execution of cryptographic algorithms, protocols, which periodically have to be updated, and so on. In order to withdraw a new security threat and keep the security credentials. So we would like to formulate the problem. So we need to create new IoT system infrastructures which will be which will enable fast and automatic change of the functionality, perform optimization and updating, and adapt to environmental conditions. So the efforts today are focused mostly on the IoT nodes, which are based on general purpose programmable processors or microcontrollers, which we have just talked about. But in contrast to them, the systems which deploy FPGA-based nodes, these challenges remain actually poorly investigated. We are aiming our approach to address these challenges with FPGA-based IoT nodes. Here we see the general structure of some IoT nodes, which contain some sensors, the data acquisition system, the processing unit with communicating with memory and with upper layers. This processing unit contains, of course, processor, and these processors can be implemented in different ways depending on the computing power which is demanded in the system. But anyway, if we would imagine application here, some Intel Xeon or Pentium or some Semtron processors, that becomes not reasonable because of high power consumption. Sometimes energy-saving processors, like for example Cortex from ARM and others, they not always are sufficient for applications. In this regard, we can talk about the usage of FPGA, because we know that FPGA are quite interesting with respect to the performance in comparing to the traditional CPUs. They can change its functionality according to the designer choice, because designer is able to create the functionality and configure these devices. And these devices usually consume less energy compared to the programmable processors. So the application of FPGA in the IoT nodes becomes more and more interesting and attractive. Here we can see some examples from real-world application of FPGA-based IoT nodes from different systems. For example, we see here we see the smart sensor for dynamic and vibration parameter extraction. Here we can see some sensor detecting classification of detection and classification of power quality, and so on. But there are several challenges which are very specific to the FPGA-based nodes. First is an effective installation of such nodes in a network. The challenge is because when we are trying to deploy such a network, then firstly we have to design the topology. Then we have to define the functions of the elements, then prepare this element, mount them on the places, and so on. Of course, each node there must be connected to the computer in order to configure the FPGA. Second challenge is when we need to change the function, the node in the network. As a result, for example, for changing the coordinates of the moving IoT elements, IoT nodes, or for example, changing the environment conditions. This change also requires to reprogram and reconfigure the IoT nodes. One more challenge is when we need to upgrade or optimize a network or some nodes without changing the functionality, like improving the parameters of operation and so on. And lastly, there is a very important challenge which is related to creation of the design for the FPGAs, its configuring, implementation of processors. Usually it takes quite a long time, of course we can take some ready-made solutions from some third parties, but anyway, this process is very laborious. It requires a lot of time to develop the architecture of the processor design, processing system design, to perform this logic synthesis, to configure the FPGA. And of course, after creation of such design, again, we need to take the IoT node back to the computer, connect it, and to download it, the configuration code into the FPGA. If we are talking about some big networks, it will take very, very long time. So the idea here in our research is to develop such a set of software tools that would receive some high-level hardware independent specifications of the algorithms which have to be executed by the nodes, and to create automatically general-purpose processors, executable files, and FPGA configurations for IoT nodes. The core for such tools that is a software that allows automatic generation of, firstly, hardware description language models of application-specific processors from this algorithmic description. One tool that we can see here is called Chameleon, is a system-level design solution which has on input some parameters and high-level description of the algorithm, which is given in C language. Then on the output, we have the VHDL description of the application-specific processor and the configuration file. This tool, Chameleon, I am showing you because the authors of this research are authors of the same tool. Yes, so this is our work. And what we do next what we need to do next is after obtaining the configuration of FPGA, we have to compile this design with logic synthesis tools. Such tools we have available on the market from the FPGA providers. And finally, after making that, we need to create some executable file for the general purpose processor, which is used in the IoT nodes, usually, which will perform some control flow. And we need to make this algorithm initially split between the IoT node processing units like processor and FPGA. And also such software is available in different, on the market we can find one of such applications is also given in our paper, which was related to computer load balancing systems. So this second part, which is related to FPGA, will be afterwards automatically implemented in from C to HDL and then converted to the FPGA configuration. And I would like now to present you a method and framework for self-configuring these IoT nodes. Let's suppose that we have the IoT nodes in the system which are operating with the operation of which is defined by the software modules which is written in C language. These software modules will be stored in the special repository in the system. And the function of each node in the system is defined according to type, coordinate, state, and environment parameters. Here we see the structure, high-level structure of this IoT systems, which contains the physical environment. Here we have fog or edge computing layer with IoT nodes, each node containing reconfigurable hardware here. And of course, universal processor memory. On the processing layer, we propose to place this module, software modules library, which I mentioned just before, and so-called IoT node configuration generation system, which contains this HDL model generation tools like Chameleon, the compiler for universal processor, computational load balancing system, and logic synthesis tools. This system, generation system, will produce configuration for FPGA and object file for the universal processor for each this IoT node. So how it works? Yes, the IoT node initially sends the type, coordinate, state, and environment parameters to the processing layer. And afterwards, then the IoT node configuration generation system will generate depending on the parameters which are given, will generate the configuration and the object file for the IoT node. And this process is done this way that firstly the appropriate software module is taken from the library, then it is distributed to two parts. One is for universal processor, second one for FPGA. The first one goes to the compiler, second one goes to the HDL module generation tool and the logic synthesis tool. And it is sent back to the IoT node. Then afterwards, the node acquires this configuration automatically after receiving this mentioned files, or the one file which is combined. How it can solve the challenges which are mentioned. This effective installation. In this case, we don't need to create the configurations in advance, because we can pre-mount the nodes into the network in given locations where it must be, and then after pre-placement, they can acquire automatically the configuration which they have to execute depending on the functionality. According to challenge 2, where if you are talking about the changes of function, the same way when the node needs to change the function, then it gives a signal to the upper layer, and it receives the needed configurations automatically after it is created. Challenge 3 is also resolved a similar way because it's related to optimization or upgrading, but the initiality is from the processing layer. And challenge 4, creating the configurations of the IoT nodes. In this case, we are absolutely making this design automatically for the processing system, because this designing the creation of the application specific processors, its logic synthesis and configuration should be done automatically when it is when this is needed. So in conclusion, firstly, we see that IoT systems which are automated in the following way, according to the given framework and the methods, they will have advanced capabilities for automatic adaptation, automatic function changing, upgrading, and optimization. We see that that we can gain new properties for our IoT systems: flexibility, functional self-adjustment, and adaptability. And as we see that the technology which is proposed further can enable the opportunity to create so-called smart networks that can be, in essence, a new generation of the networks in the future. Okay. So that's all from my side, and I'm ready to answer on your questions, please.
Thank you so much for the presentation. Dear colleagues, any questions? Dear colleagues? Okay, thank you so much for really interesting and deep research that we saw on the presentation. And could you please tell us what are the further steps in your research? What is the further development of the system? do you have any plans?
Yes, of course, we have plans. And firstly, I would like to focus, if we are moving to that structure back. Here we see the need for organizing interaction, firstly between these tools, because we have, for example, we as authors of this research have some results on creation, firstly, of the application-specific processors generation tools, this HDR model generation tools, and computational load balancing systems. Now we see the task how to organize the interaction between them, because and interaction with the logic synthesis tools. So this is we see the first future task for us in this communication. And after it will be done, we can move to the practical implementation of this proposed technology.
Thank you so much for the answer. If there are no more questions, thank you once more again so much for the presentation, and we go to the next presenter. Our presentation is by Olga Pavlova, Tatiana Vrushenko, Andrei Kuzmin, Timur Isayev, and Huda El-Boukhisi, method of early landfill fire detecting using the YOLO V8 neural network. Are the presenters here?
Yes.
Please.
Hello, dear participants of the conference. My name is Andrei Kuzmin, and this is Timur Isayev. We are master students of Khmelnytsky National University, majoring in computer engineering. Let us introduce the method of early landfill fire detection using the YOLO V8 neural network. In May 2016, there was a fire at the Rybovichi landfill near Lviv. 4 people died due to a debris slide. The work of the landfill was stopped. Garbage from Lviv started to be taken to other landfills in the region and Ukraine. Unfortunately, such incidents are not rare in Ukraine because of the accumulation of methane due to the decomposition of waste and due to the increases in the average annual air temperature, global warming. Fire often occur in landfills. They are dangerous because they spread quickly, occupying a large area, and harmful and poisonous substances into the air, and are difficult to extinguish. The slide shows extinguishing a fire at landfill near river. The fire covered an area of more than 300 square meters. To eliminate the fire, 6 rescue tanks, a tactical robot, 3 local fire brigades, and equipment serving the landfill were involved. Timur and I are from Khmelnytsky city. This slide presents the Khmelnytsky solid waste landfill, which is located on the territory of the city. These photos were taken by us as part of the tour organized by the Khmelnytsky Smart Environment Office. We visited the municipal landfill with our supervisor and other students who are interested in this problem. Admittedly, its scale is impressive. Therefore, the relevance of our research lies in the development of an information system based on machine vision, which will help to detect a fire at a landfill as early as possible and prevent the spread of fire, as well as its terrible consequences. The proposed system consists of three subsystems: surveillance subsystem that includes CCTV cameras at the landfill area, image recognition subsystem that uses the pre-trained neural network, and alarm signals subsystem that provides the conclusion about fire or the absence of fire at the landfill. The architecture of the proposed system is shown on the slide. For the architecture of the proposed system is shown for the operation of the proposed system. Method of early landfill fire detective was developed. The method consists of 6 steps: preparation and training of a neural network model on a data set with smoke and fire, classification, validation of the neural network model on real images of fire at landfills, automatic detection of fires at landfills in videos from outdoor surveillance cameras, and saving images using the existing YOLO-V8 models using Python program, manual verification of recognition results, separation of cases of false detection or of fire or smoke, evaluation of the automated detection quality, manual labeling of incorrectly processed images. In the case of study, the experiment with the YOLO-V8 as neural network were conducted. For the model training, a method of supervised learning was used. It consists in the fact that the algorithm is trained on a pre-classified data set, which simplifies the search for objects, for recognition, and increases the accuracy of recognition.
Training of the model was conducted on RoboFlow dataset with two classes, Smoke and Fire, using Python programming language and Google Colab environment. An example of image classification of the above-mentioned dataset and examples of the images for the training are displayed on the slide. A YOLO-V8S model was chosen as it has optimal parameters for solving this task. The results of YOLO-V8S model training are shown in the table on the slide. Number of apples was based on a trade-off between training time and model performance. This slide presents the evaluation metrics. We can see that at first the accuracy of the recognition was not so high, but later it increased significantly. This slide presents the precision confidence and recall confidence curves. The precision confidence plots the precision value at different confidence thresholds. Starting from a high confidence threshold, the precision will be relatively high because only confident predictions are considered valid. A recall confidence curve shows the recall at various confidence thresholds. You're looking for a high recall across the board. The precision recall curve is constructed by calculating and plotting the precision against the recall for a single classifier at a variety of thresholds. For example, if we use logistic regression, the threshold would be predicted probability of an observation belonging to the positive class. Confusion matrix and confusion matrix normalized are presented on this slide. Precision, recall, and FR metrics were also calculated. Precision shows how many positive predictions turned out to be correct. Recall represents the proportion of positive cases correctly identified by the model. And the if1 score is metric for measuring the performance of a model in classification tests. It combines accuracy and response into one metric to provide a balanced assessment of model accuracy. The results of the algorithm operation on the subject of smoke and fire detection on real images of landfill fires taken from the internet are presented on this slide. However, we can see that the smoke and fire on these images is significant. Further steps in our research will be devoted to training it at images with a small amount of smoke, and train it how to distinguish smoke from the fog and other visual touches that can influence quality of the recognition. In the course of the study, the concept of information system for the early detection of fires and smokes using machine vision was proposed. To demonstrate the operation of the system, experiments were conducted using the YOLO-V8S ANN model, which was trained on the Roboflow dataset in the Google Colab environment in the Python programming language. The training dataset contained two classes, smoke and fire. The results showed an average accuracy of 93.7% of the time, thus maintaining a low false positive rate. In addition, the model achieved a high recall, successfully detecting 90.6% of the real objects and showing a low false negative rate. The F1 score was 0.92, reflecting a balanced trade-off between precision and recall. These metrics collectively suggest that the YOLO-V8 model is both accurate and robust, making it a reliable tool for early detection tasks. The promising results highlight the potential of the model for real-world applications where high accuracy and reliability are important. Thank you for your attention.
Thank you for the presentation. We have questions. So please, Pavlo.
Yeah, thank you very much for your interesting talk. I would like to clarify, did you justify somehow technically the word early detection, or I mean early landfill fire detection, or that just the approach for an end user? I mean, for example, if you chose the title of your work, like method of landfill fire detection without early, wouldn't be it the same? I mean, did you technically somehow justify this word early, or did just like matter of wording? That is the first question.
Thank you for your question.
Let me answer this question. The boys will answer the next questions because I was the co-author of this work and the supervisor. So yes, that is a big research that we saw just the beginning of this big research in this presentation. And yes, Pavlo, you were right. It was like the first step, it was just simply fire detection at the landfill. And it was not really the method for early landfill fire detection, just like the first steps to detect fire and smoke. And the further steps in this research will be the approaches how to make it as early as possible. So thank you for your question, and we will work further on this topic, on this approach.
Okay, thank you very much for the clarification. I wish you very much good luck. And another question, I should say sorry in advance if I misheard this, but did you train your YOLO version 8 from scratch, or did you use any transfer learning on some other domain adaptation techniques in order to prepare the model specifically for this dataset? Because as far as I am aware, training YOLO, especially starting from version 3, is a hard task, especially in terms of the time. So did you do it from scratch, or maybe some other special techniques were used? Thank you.
Timur,
Thank
can
you
you
for the
answer
question.
this question?
Yes. So we started with a little research and found out about the RoboFlow service that provides open source datasets for the image classification. And we found out about the pre-processed dataset which contains like images with smoke and fire, with two classes, smoke and fire. So we use that, and we use the supervised learning to get more accurate results.
Okay, thank you.
We have more questions, please.
There are others. The work is very good and interesting, but I have two questions. How does the camera resolution influence the speed and probability of correct detection of smoke or fire?
Let me answer this question,
Okay.
if you let me. Actually, that was just the beginning, as I previously said, of the experiment, and we haven't used the real images from the camera from the landfill that we showed you on the photos. We just used the it was like the approbation of the method using the ready-made pictures from the real fires that we found on the internet. It was the fire on Khrupovichy landfill and the fire near Rivne. However, there are some factors that may influence on the early fire detection, such as the ability of like small smoke, but not fire. Yeah, and in this case, the camera resolution impacts a lot. That's why we are planning to conduct more experiments. One of them is to train our network on the subject of, for example, weather conditions recognition to maybe eliminate the misrecognition, for example, smoke and the fog, and some other experiments that will help us and that will allow to clarify the results and make them more accurate.
Okay, I think a smartphone camera must be sufficient for such experiments, that the work is has very good quality and results. Thanks.
Thank you for the question and for your suggestions. Dear colleagues, more questions, please. If there are no more questions, then thanks, guys, for the presentation, and we go to our last presentation for today. The last presentation is by Христина Ліп'янina-Гончаренко, Natalia Maika, Anatoly Sachenko, Lukasz Kopania, and Mariana Soye. A cyclical approach to legal document analysis leveraging AI for strategic policy evaluation. Are the presenters here?
Yes, our presenters is here, and good afternoon, and thank you for your invitation on the first international conference. And at first, I want to congratulate with the important celebrating today for our country. It's the Constitutional Day, and wish all glory, victory, and peace for us. The research of our work is a cycle approach to legal document analysis leveraging AI for strategic policy evolution. It's very interesting sphere because was analyzes and working with together from scientists from different sphere, like techniques and light legal. I represent a legal part of this research, and sorry if answer on all questions in technique not as first, because I'm legal education. Okay, I start my presentation. Okay, do you all see? Okay, at first, I want to say that top slide statement of this idea of this research problem statement is that today it's practically impossible to imagine our life without IT intelligence, and legal sphere is too, and the integral matter of concept for the development of new technologies is diverse and distinct. A lot of country development and that are development adopted AI strategies to depended their politics in this sphere. Despite the similar of general tasks, principles, and methods, AI strategies must each time be adopted to unique conditions, leading to different paths towards the more or less similar general goals of the international community. Therefore, a hot problem is the analysis of AI development strategies, is regarding key aspects of development and legal implementation at the national level. The research presents a new cyclical approach to the analysis of legal documents based on the application of advanced AI algorithms. The aim of the study is to develop a comprehensive method that will automate the processes of analysis, classification, and assessment of compliance of legal documents with established norms and standards. It is demonstrated how the application of this approach can optimize the processes of working with legal text, improve the accuracy of the analysis, and contribute to effective decision-making in the legal sphere. The study also emphasizes the importance of regulation and standardization in the use of AI technologies in jurisprudence, considering potential threats to data confidentiality and security. The structure of this work was organized such a way that it entirely presents a review of exciting AI research and technologies used in legal field, and describes in details developed cycle approach and its implementations. Okay, about related work, a lot of scientists' work were analyzed in this sphere, and we also want to note some of them. Writing some important conclusions in this sphere is at first that legal technology encompasses the use of various technological tools and innovations to improve legal practice. First, the majority of the resolutions in the field are presented in text form such as judgment, documents, contracts, and legal opinions. And in this sphere, also using natural language processing and LQR, linguistic equality. Research on the field of document analysis with cycle processing, information extraction, machine learning demonstrates a wide range of application and methodologies in this sphere. Please look in the table 1, we below is a comparative of approaches and quantitative assessments of the closest analogues among scientific articles. Our approach was at first used of AI-based software to improve speed and accuracy of analysis, and a quantitative assessment is that not specific numerical values given, but a significant increase in speed and accuracy not. Second was implementation of deep learning for text classification and legal document review. In this assessment is classification accuracy, performance across multiple documents classes. And third was integration of AI and machine learning for document analysis and accuracy prediction. About assessment as prediction accuracy, it's near 0.89, improving in document analysis accuracy. About compared to the closest studies, this study demonstrates higher accuracy, 0.91 in the analysis and classification of legal documents due to the integration of advanced machine learning and natural language processing algorithm. Therefore, the study not only ensures high accuracy of analysis, but also shows better adoption to various aspects of legal documents, making it a more efficient and reliable tool for legal analysis and strategic policy evolution. The approach to analyzing documents and extracting relevant information can be considered a sequence of operations that includes text analysis, pattern recognition, and data categorization. The objective is to transform unstructured textual data documents into a structured form based on a prudential categories. This includes several steps. First, it was text processing, feature extraction, classification, and information storage. Text processing is include tokenization, the division of text into word and phrases, normalization, converting text to a uniform case, removing punctuation, classification was a use of document features to classify into predefined categories using machine learning models. And the last, information storage, includes the classified information in stored structured format. This approach integrates scientific text processing methods and mathematical principles of classification to automate the process of extracting information from textual documents, ensuring efficient and correct data processing. We will illustrate this approach with figure 1, which would be below, which depicts an algorithm with several steps, beginning with the definition of the table structure. Step 1, define structure, moving to the listing of documents for analysis. Step 2, list documents, processing each document to extract information corresponding to each category. Step 3, process documents, filling the table with extracted information. Step 4, populate table, exporting the table to an Excel file. Step 5, export to Excel and providing access of the method for the download on accessing in Excel file. And step 6, access Excel file. Steps 3 and 4 indicate a focus on detail. Step 3 involves the cyclic processing of each document to extract information, and step 4 involves the cyclic rotation on new rows in the table with extracted information. This picture, this process is all optimization document recycling processing. And you can see all steps. Steps 1, steps 2, steps 3, steps 4, step 5, and step 6. All this processes was illustrated in this picture. They implemented the proposed method analyzing AI development strategies, section 3. NLP and machine learning methods were used specifically written libraries such as Analytica for text processing, Stickland for feature extraction and classification, and Pandas for structuring and storing data in tabular format. For achieving specific goals, data were used that were collected from official state websites, governments, international organizations, namely to the full text of concepts, development strategies approved at state and international level. Based on the analysis of AI development strategies in 10 different countries and regions, a systemic table was formed that reflects the key aspect of each strategy. This approach allows for the assessment and comparison and the presence of AI development, specific legal regulation, both rigid and flexible approaches, the definition of specific goals in the national level, the definition of concepts, as well as the presence of the high-level and practical guidelines, from principles to AI implementation. Therefore, to analyze this issue, experts in jurisprudence have proposed the structure in table 2. Please look. Here is the structure of results, parameter, and description. Country, the name of the country and region, AI development strategy reflect whether a country or region has officially formulated AI development strategy. Legally binding regulation indicates the presence of legally binding aimed at regulating AI. Not binding regulation, specific targets, AI definition, high-level guidance, and practical guidance. Based of the proposed approach, table 3, with the AI results for 10 documents was formed, and simultaneously 5 experts in jurisprudence were also asked to form a corresponding table. If you see, we take some countries, and with natural learning and machine learning, we cycled these methods from this table. It was made by machine learning also, and also legal only checked is it correct. Table 3 represents the effectiveness of AI analyzing AI development strategies in different countries. A comparison was made between the results of data processed and the result of expert evaluations. You see text red and black. Red is not at all correct, and we can use this was checked by a legal, and you see that AI not always correct in his analyzing. Okay, in the study of effectiveness, the method of direct comparison, results obtained by a US expert rating across a range of key parameters was applied. The accuracy of the IE was determined based on the percentage of agreement between the IE generated data and verified expert data. The overall effectiveness of the IE analysis was measured at the average accuracy across all categories, which allowed for an assessment of its ability to adequately understand it and interpret strategic documents in the field of IE development. The following criteria were defined within the method for evaluation. Full match between the result obtained by IE and expert data was scored as 1 point, indicated in technical information and high accuracy of IE analysis. A partial match where IE used the assumed marker to assess parameters that were acknowledged as correct by experts was assigned a score of 0.9 points. This reflects a high level of consistency in results, albeit with some degree of uncertainty in interpretation. A complete mismatch where the information provided by IE did not correspond to expert assessment received 0 points, indicating a complete divergence in inferences. The analysis of Table 5, which demonstrates a comparison of results obtained by IE with expert evaluation, revealed a high overall accuracy of IE in identifying IE development strategies by countries and categories. The average weighted accuracy across categories is 0.91, which indicates the effectiveness of IE in understanding and analyzing complex data. All showed the highest accuracy in specific targets category with a score of 1, and IE development strategy with an overall accuracy of 0.91. However, in categories such as legally binding regulation, not binding guidelines, IE definition, high-level guidance, and practical guidance, a somewhat lower accuracy opus rate ranging from 0.89 to 0.8, which may suggest the need for further improvement of IE algorithms for better identification and interpretation of these aspects. Please look in the table 5, and you can see the accuracy by category. The highest category has of countries was in Brazil and also in China, USA, China, and Colombia. Okay. That in conclusion of our result, that the result of the current research demonstrates the significant potential of applying IE in the process of analyzing legal documents, confirming the effectiveness of the proposed cycling approach. The overall data processing accuracy using IE was 0.91, indicated high reliability and precision of the obtained results. Particularly impressive results were achieved in the category-specific targets and IE development strategy, where the accuracy was from 1 to 0.91, respectively evidencing IE ability to precisely identify key elements of IE development strategies. Based on the comparison conducted with expert evaluation, we confirm the high effectiveness of IE in analyzing IE development strategies at international level. Based on the conducted analysis, future scientific research should focus on developing improved algorithms to increase the accuracy of classification analysis of legal documents, particularly in categories like legally binding regulation and practical guidance. And for Ukraine, it is was noted that very low was accuracy because maybe it is a problem Ukrainian language. Okay, thank you for your attention. Maybe have somebody questions.
Thank you so much for the presentation, dear colleagues. Do you have questions to our presenter? Okay, then let me ask the question. Dear Natalia, could you tell us what is the form of the implementation are you going to use for your system, for your approach?
As you know, in our research, we are using 2 methods, natural language and machine language. And today we don't have so good technologies in legal system, and we need smart legals, a physical person that can be used in this system. That's why I think we all depend on from our development of technologies, and maybe about 3 years, 4 years, we can be implementation of these strategies and all country, and and I think the first country and it's China and USA, because they have a lot of investigation in this sphere. Thank you.
Thank you so much for the answer. Dear colleagues, more questions, please? If there are no more questions, then I would like to thank you all for the fruitful cooperation, for your speeches and for the presentations. And now we are going to have a coffee break for 5 minutes. And after 5 minutes at 2 p.m., we are welcome you all to the second session of our conference, of our workshop. Thank you so much, and see you at 2 p.m.